you have a PDF of this handout. If you have print out, or just save it somewhere on your computer. But it basically outlines all the methods and the way how you can think about them if you look at the expression. So the point is that before we had topics, different methods, and we had examples to illustrate them, right? But we come to the place where you might be given an example and no one tells you what method to use. So then how do you even know what to try? Is it a grouping method, or it's maybe a formula? Like, how in the world do you know that? Well, this handout, again, is meant to help you to get to the right method. And the way it's structured, it starts kind of, see how on the left it says step 1, step 2, step 3. So you start at the top of the handout, and it shows you the first step. And the first step is to, for any expression you're given, that's something that you always want to try first. You want to see if terms have a GCF, or there's something common that you can find in all terms. And if you can find things like that, then you pull that GCF out. That's what you start. Now, once you, let's just go over that handout real quick, and then we'll do maybe like two quick examples. Once you factor out the GCF, you're going to look at what's, well, actually, you know what? Let's do an example, and I'll illustrate this handout with an example. I think it makes more sense. So here on the right, I have an example. Can we? So we're trying example A, this one. Look at this expression. It looks pretty, I know, pretty bad, right? I mean, high power is, I mean, it's not looking good, and it's kind of even hard to say what to do with it, like what method to apply. But the only thing we know so far is to apply the GCF. Well, is there GCF for those 3 terms? I think they're definitely something that they all have in common. Let's start with numbers. So we have 8, we have 56, we have 80. What is the highest number that divides 8, 56, and 80? 8. That's right. So that's going to be part of the GCF. Now, they all have X, right? I make sure that all of them, not just 2 out of 3, not just 1, but all of them have to have same variability. They all have X. It means that GCF will have X. And here I have to find the lowest power of X. So it's power 4 in the first term, power 3 in the second, and power 2 in the third. Okay, so it looks like 2 is the lowest power, right? So GCF will have X to the second power. And they also have, all of them have Y. Oh, and it happens to be like exactly the same, right? It's Y cubed. So they all share Y cubed, not sure, but they all have Y cubed, so it's common factor. And over here, so Y cubed is going to be part of the GCF. Well, we're trying to pull out the GCF, right? Factor it out. So it means that I'm opening parentheses. I need to write down what's left as I pull 8x squared Y cubed out of the expression. And the way I think about it is by going backwards, by what do I need to multiply GCF to get each term? So by what do I need to multiply 8x squared Y cubed to get me the first term?
X squared.
So you're right. So x squared, that's it, right? We don't have anything else. So 8, I will need to adjust. Y cubed, I will need to adjust. Yeah, just x squared times x squared will give me x to the 4th. Perfect. Next one. 8 times what is 56?
X.
7.
Sorry,
7, right? I'm going back to, so yes.
it would be 7x.
8 times 7, 7, and we need x. Because we have x squared, we need to get x cubed. So we need another x, 7x, and then plus 8 times 10. Very good. Anything else? X squared we already have, Y cubed we already have. Okay, just 10, perfect. Okay, so that was step 1, right? So you start with that, and then notice that after you factor out the GCF, what's left inside the expression looks much more better than the original expression, right? And what do you do after that? Then you continue with step 2. So let me enlarge now, I'll go back to the example. In step 2, you literally have to just count the number of terms. And the options are your expression, well, where are you counting them? You're counting them in that remaining expression. So we already got the GCF out. Now you're looking at the remaining expression inside the parentheses, and that's where you count. So, well, obviously we have 3 terms, right? 1, 2, 3. But what are the options? So it may happen that you counted 2 terms, or you counted 3 terms, or you counted 4 terms inside the parentheses, right? So these are your options. And based on how many you counted, well, you're going to be using different methods. Let's go quickly over what it says then. So if your expression inside the parentheses ended up having 2 terms, then what are your options? Well, you're going to use formulas. And you have options for formulas. Either it's going to be formula for squares or it's formula for cubes, and that's going to be kind of like obvious, right? If you see squares, well, then try to pull out formula with squares. If you see cube, x cubed, then we'll try formula with cube, right? So I think it's not going to be hard to distinguish which one formula to attempt. That's when you have 2 terms. Well, if expression has 3 terms, that's actually our case, right? Our case is this one. Our polynomial or expression inside the parentheses has 3 terms. Well, again, you have 2 cases there. What are those 2 cases? Well, we already talked about them. That's when you do have a number in front of x squared and when you don't have a number in front of x squared. What can we say about our expression? Is there a number in front of x squared?
A 1.
1, right? So that's when we consider a known number, right? That's the case with no number, and that's the short one. So on this handout, it's going to be this one, no leading coefficient, or a equals 1, right? And we're going to go with the short method. Well, if you found a number in front of x squared right here, then you would use the long method, right? So that's how you finish. That's how you know what to do. And then finally, if your expression inside the parentheses ended up with 4 terms, then you're just going to use factoring by grouping. So this handout kind of meant to help you to decide on what method to use. And it's basically by the number of terms. But don't forget to do the first step. And that's usually something that kind of gets forgotten. It's important to always start with this, like step 1, always try to factor the GCF. Now, in some cases, you won't have a GCF, right? It says F if any. So if expression does not have any GCF, well, then move on to step 1. To step 2, then start counting the terms. Okay, well, let's finish this one. Do you guys have any questions about that handout? Does it make sense the way it's structured? Okay. Yeah, let's finish our expression. So we said that it's going to be the short method. It means the following. So I'm going to rewrite it. What I'll write, I'm going to put that GCF. It's still there. I'll have to move it from step to step. It's always there. But then since I'm using the short method for this trinomial, I already got to prepare 2 parentheses because that's how the short method goes, right? I'm going to put x and h. And now I will play this vector game. So we start with a number at the end, the constant at the end. So that's 10. I have to split it up in such way so that I get -7 as the sum. So what number should we use?
1 and 10.
Let's try 1 and 10. Okay, so let's check. Now 1 plus 10 is 11. That's not what we need, right?
-2, -5.
-2, -5. Okay, so we'll try that. So that didn't work. You said -2 and -5. So first I'll check. -2 times -5 is +10. Very good. So we always make sure that signs work. And then as I add them, I get -7. Perfect. That's what we needed. Okay, we got it. So then that's what I put inside the parentheses, -2 and -5. And that gives me the answer. So actually it was not that bad after all, right? And I feel like that step 1 really does the magic, where you factor out the GCF and then things go smoothly. And while we're copying that, I'm gonna put down one last example. By the way, so technically the way I should ask this question is the following. I should say factor completely. Okay. Factor completely. And the reason I have to have that word is because, well, if I go back for a second to the previous example, once we factored out GCF, well, we did factor the expression, right? So after we did this first step, we had two factors. We had GCF times this expression. Well, it's a product, so it means that we factored. But that was not considered to be factored completely because we had more steps to do. We could continue and we could factor another expression. So what happened is that at the end, we end up with three factors. That GCF, x minus 2, and x minus 5. And we stop factoring only when we cannot do anything else. Only when we cannot split up anything else in more factors. So that's what means to factor completely. And that's going to be a question here. So what is step 1? Now we're going back to that handout. Step 1, the important one, to factor out the GCF, after which things should look good. So what will be the GCF for this expression? So we have numbers 7 and 28.
Would it be -7?
Let's just do positive. Technically, we could factor out -7. I would suggest for GCF just keep it positive whenever possible, unless like ruin something later on. But in this case, we'll use +7, even though actually negative would work. But it's definitely 7. How about variables? So both of them have x and y, so what power should I use?
Cube.
Cube for both, right? So it's x cubed in both, so that's definitely something they both have in common. Now y is to the 5th power in the first case, and the 3rd power in the second case, we pick the lowest power, so y cubed. Now, for the first left over from the first term, we have what? So 7 times 7x cubed y cubed times what gives us the first term? So we have 3rd power here, so, and we need to get 5th power. So it's going to be 2nd, right? Y squared minus, and then 7 times 4 gives me 28. X cubed I already have, y cubed I already have. Okay, so it looks like it's just 4, right? Y squared minus 4. So we got that part. That was step 1. Step 1, according to that handout. Step 1, we did find GCF and we factored it out. Then we have to go to step 2, and we have to count the number of terms, right? So how many terms do we have in this expression? So terms are things that are being added or subtracted. Like, don't overthink. It's not a tricky equation. So it's 2. Yeah, it's kind of like whatever you see. Don't overthink this part. It's 2 terms. 1, 2. And then above, in the first example, we had 1, 2, 3. So terms are separated by pluses and minuses, right? That's what we count. So that's very intuitive. So don't overthink that stuff. It's 2 terms. 2 terms. Okay, so according to this handout, when we have 2 terms, that's our case now. Polynomial has 2 terms, right? This one. Then we have options, either using formula for squares or trying to use formulas for cubes. Obviously, where is my expression? Well, I don't know. Which one do you think it is? Which one we should try? Formula for squares or for cubes? As you look at this expression, what should we try?
Cubed.
Now, as I look at this expression, what I see, I have y squared, right? And I have 4. Now, 4 is just a number. I don't even see any powers. But notice how y is raised to the 2nd power. That's going to be a hint for me to use formula for squares. Have 2nd power. So that's the one we'll use. And we have minus sign. It's good. So we should attempt it. If it was with plus, then we would be done. What's left to do is just to rewrite it as as squares in every term. So y squared I have, but then 4 I can write as 2 squared, right? So now those 2 squares are obvious, and according to the formula, I have to set up 2 expressions. So what do you guys think I put inside the expressions?
Y plus 2.
Y plus 2
And y plus 2.
And y minus 2, right? They're always going to be different signs, plus and 1 and then minus another one. And that's it. That's the answer. three-step process basically, but we had to use factoring like a few times. First the GCF, and then applying another method. So that was step 3 right here. Noticing the formula to use. So that's overall the idea for using this handout, and that's the strategy for factoring. Everything is based on the number of terms after you pull out the GCF if you have one. Are you still alive?
Still alive.
Okay, good.